Okay, so thanks everybody. We're going to talk today a little bit about test-driven development and a little bit about YUI Test together. And one of the things I've always been interested in is how to bring more professional treatment of JavaScript to people. So I first started writing because I felt like JavaScript wasn't being treated like a real language and it deserved to be. And so over the past couple of years, we've seen a lot of stuff coming over from other disciplines, design patterns, and all kinds of tools, debuggers, profilers that have traditionally been used in other types of languages finally making their way into JavaScript. And one of the things that hasn't quite made it yet is the concept of test-driven development and unit tests, and really just taking a critical eye towards JavaScript code quality. So that's what I'd like to introduce you to today. So test-driven development, as with any other type of development process, always begins with designing features, right? So you need to know what it is that you're supposed to build before you actually start building. Where it differs from more traditional ways of development that most people are used to is that the next step after defining your features isn't to start writing code to implement it right away. The next step is actually to write some tests against what you know that you should be implementing in your code. And the idea of these tests is that they're testing for specific things that will let you know that you've completed your job. And so with these tests written, you can go and start writing your code and run it against your tests. And as long as things are passing, you know that you're on the right track. Once you're done writing the code, or go back, run the tests as many times as necessary to make sure that you've got all of your bases covered. And then once you're done with that, you go back and look at more features that you're supposed to design. So why test-driven development as opposed to what you've been doing already? Really, it comes down to there's no such thing as a small change. When you're working on an enterprise JavaScript application with thousands of lines of code, any one single change that you make can possibly impact the entire rest of the application. So how do you know that the changes you just made aren't affecting something in some different file that you weren't even looking at because that wasn't what you were supposed to be doing? Test-driven development helps you to specifically identify your tasks and what it is that you're actually supposed to be doing at this point in time. It ends up giving you essentially a checklist of things that you should be doing in order to implement the feature, so you can really determine when you're done. You understand your code the best at any given point in time, and certainly at the point in time at which you're writing it. Right? The normal sort of software development process is you write some code, you put it out there, some poor QA person has to come along, figure out how it's supposed to work, and then try to report back to you if something is broken. And that means that they have to relearn everything that you already know about your code. It would just make sense if while you're writing your code, you write tests because you already know how it should be working, and then those tests can be run by anybody else, and they can pass those results back to you. And it's a lot better than somebody saying, hey, your thing isn't working. Right? You'll actually get a list that says, look, these 3 tests are failing, can you take a look? And that gives you a starting point at which you can start debugging your code. It does take a little bit of an upfront time investment to write these tests, but it pays huge dividends later on. Because at any point in time after you have these tests, you can make changes and then just go and rerun the tests, and you can be assured that you didn't break anything else. QA resources are usually limited. I have never been on a team that had too many QA resources. And because of that, it's really useful for us to kind of step in and test our own code. As we were just saying, I already know how my code is supposed to work. So why not write something to test that it actually is working the way that I know it should? And then anybody down the road can run that and report these errors back to me in a way that's useful. And really gives you a great peace of mind because all you have to do is a quick sanity check is to run through all of the tests that you have after you've made a change to make sure that you're not committing something that is totally going to break your site. And it doesn't have to be just you that can do it. Anybody can do it. Right? You point your browser to a URL, just say, hey, if anything turns red, let me know. And you don't have any surprises later on. So we're going to take a walk through this test-driven development process with an example, just to show you what it would look like if you're actually going to do this yourself. So we're going to start out and design a feature. So features always start out with some sort of requirements. They're usually functional. Right? Somebody doesn't say to you, please write me a function that does this. They'll come to you and say, the user has to be able to do this, and it's up to you to translate that into some sort of code. So it's usually going to be translated into interfaces, which are objects and methods. And then what you really want to do is, for those interfaces, describe what the expected inputs and the expected outputs are. So inputs are traditionally thought of as the function arguments. But it can also be anything else that is in the environment that function is reliant on. So any global variables or global objects that need to be in a specific state. Outputs are not only just return values, but it could also be an error that should be thrown in a particular case. It could be the state of some object is being changed once this function is being run. It's important to really understand those inputs and outputs. And so if we're going to go for a practical example here, somebody comes along and says, when a username is entered, ignore spaces at the beginning and the end of the text. So you as an engineer say, okay, what that really means to me is I need a trim function, because I need to ignore the white space at the beginning and the end. It probably just makes sense to strip it out. So you stop and think about it and you say, okay, what does a trim function do? Well, it removes leading white space. Right, so if there's white space at the beginning, we should remove that, and then we should return the result. If there's trailing white space, then we should remove that and return the result. Okay, so now we have a pretty good definition of what it is that we want to build next. So we'll move into the writing test phase. And this is where we're talking about unit tests. Basically, unit tests are designed to test a very small part of your code, aka a unit. And as far as object-oriented programming is concerned, units are typically equivalent to methods. So you want to be writing tests that are testing out your individual methods. And again, the inputs and the outputs are important. You basically want to go through and test, given this, I expect such and such a result. And you want to do one set at a time so that you don't end up getting mixed results and maybe get a failure on one set of inputs when the other set was absolutely fine. And basically each test should say, given this input, I expect this output. That's its only job. So some of the complaints that we see about unit testing, ramp-up time, just takes me too long to get involved with it. I just want to really get in and write some code. Unfamiliar syntax and concepts. I don't understand what all of this assertion stuff is. Doesn't make sense to me. I don't know what to do afterwards. I just don't want to do it. The test harness setup is hard. Like, if I'm going to run something, it has to be instant. And if it's not instant, I don't want to spend the time to set it up because I got too much work to do. Writing tests takes too long. So again, you have to learn a new way of doing something. You have more code to write in order to write these tests, and people just don't want to do it. And the other common complaint is you can't figure out what broke when a test fails. These are all, to some extent, valid complaints, but they can all be dealt with. And this is where YUI Test comes in. So YUI Test is primarily a unit testing framework for JavaScript. And it's built on top of YUI, clearly. And it is also used by YUI to test the code internally. And when you download the YUI zip file off of SourceForge, there's a directory in there called tests. And that actually has a bunch of the YUI tests in it. So you can, at any point in time, go in there and run tests against any of the YUI components that you want. There's a bunch of documentation available on YDN. So you go there, you see a nice page, tons of text, tons to read. There's some narrative documentation that can walk you through setting up your code in order to do tests. There's a bunch of functional examples that you can play with and figure out why they work the way they do. Some API documentation, and then cheat sheets. So typical YUI, a lot of documentation, a lot of coverage to help you get up and running as quickly as possible. So some of the goals of YUI Test, one was we wanted to make it easy to write your first test. Going back to some of the earlier complaints, people say it takes too long, I don't get it. It was really designed so that you could look at an example and say, okay, I get it now. If I just follow a few of these basic rules, I can get my tests up and running really quickly. Really important goal, because we didn't want anybody to sit back and say, I don't have time to write a test. The syntax is simple and pretty straightforward. Again, I think that you'll find once we get into the examples that you'll be able to look at it and pretty quickly figure out exactly what's going on. It works the way that JavaScript works. There were some other unit testing frameworks that I came across for JavaScript that tried to introduce concepts that just weren't all that familiar to JavaScript. And that's usually because they were ported from some other language somewhere. And at least in my mind, that's just another barrier to get people to actually start writing tests. So as much as possible, YUI Test uses as many familiar JavaScript concepts as possible. Again, we wanted you to be able to get up and running fast. So there's really not a lot of code that you need to write in order to start getting your tests running and getting results. And another thing was to help with the complaint of not understanding what went wrong is for any sort of failures that go on, there's useful error messages out of the box to try to tell you what went wrong. There are options so you can put in your own messages to really kind of hammer home what it is, but you don't have to. There's enough logic around the messages that you get by default that you should be able to figure out exactly what went wrong. And a really big goal for me personally was to make sure that this could work with any JavaScript code and that you didn't have to be using YUI previously in order to get this to work. So if you're writing code using any other type of JavaScript library, you can still use YUI Test to test it. So if we're going to get started, basically the first step, create an HTML page like anything else. Just include the required JavaScript and CSS files. That list is up on the YDN page. Include the JavaScript that you want to test, obviously. Write one or more tests so that you actually have something to run. And include some boilerplate JavaScript at the bottom to get everything all set up. Just open your page in the browser, and that's pretty much it. And you get to see your results. So the base of YUI Test requires you to create a test case, and it's in pretty simple syntax. You create a new instance of yahoo.tool.testCase and pass in an object literal. You need to put a name property on it, and that's really for your own benefit to make sure that you can identify what this test case is actually testing. And then you can add any number of methods after that. So any method that begins with the lowercase word test is considered to be a test, and it will get run when all of the tests on the page are run. Any other method that doesn't begin with the word test is just considered to be a helper method that you're using to write your tests, and so those won't get picked up automatically. So you have a lot of options in defining this object. Put in as many methods or as few methods as you want. Just make sure that your tests each begin with the word test, and you'll be ready to go. And then this was the boilerplate code I talked about a minute ago. Really, you just need to add your test case onto the test runner. And then when the page is ready, you want to instantiate a test logger, which displays the results for you, and then just run the test. So this can just be copied and pasted pretty much from page to page. Doesn't really have to change. So an example of this. If we go back to our trim function, which we said there were really two requirements for that, having to do with the leading and the trailing white space. So tests for this would look something like this. We have a test case. The name is trim test, because that's the method that we're testing. And the first test is to test with leading white space. And basically, I'm just calling the trim function with a string that has some leading white space, getting the result, and then I want to make sure that that result is what I expected. And what I expected was hello world without that leading white space. So I can use the yahoo.util.assert object, which has a number of methods on it that allow you to do all kinds of comparisons. And in this case, I'm just using r=, which basically compares two values using the double equal sign. So it expects the first argument to be the expected result. So that's what you think that it should be. And the second argument is what it actually is. And when that comparison happens, r= will throw an assertion error if they're not equal, and that will cause the test to fail. And the next test is pretty much the same. It's just testing for trailing white space instead. Same basic setup, call trim, pass in the input that I'm expecting, and then test the output that I'm expecting. And so when I run these, immediately I see that the tests have failed. And of course they failed because I haven't written my trim function yet. Probably can't read it, but it says unexpected error, trim is not defined. Except that was pretty expected because I haven't written it yet. But at this point, failing is good. Right? You want those tests to fail initially, because if the tests pass, then what are you supposed to do? Clearly the stuff's already done, so you move on. So you want your tests to fail at this point in time. And next you're going to write the code. So as you're implementing the feature, what you want to do is start with the first failed test, and just that test. And basically you want to write enough code to just make that first test pass. Don't worry about any of the other features that you know have to go into this function. Just worry about making that first test pass. And once you've done that, that's when you go on to the second test and implement changes to make that pass, and so on and so forth. So for example, here's a very simple trim function. And remember, this is targeted at the first failed test. And so that was with leading white space. So that's what my trim function is right now. I'm going to go in, I'm going to run my tests. Say, cool, so the first test passed here. See, it turned green in the test logger. It says test trim with leading white space passed. Awesome. The other one failed. So as long as you have a failed test, that means you have to go back and write more code. So we'll go back and take a look. OK, so now I'm going to add a little bit extra to my regular expression. And I'm going to take care of the case for trailing white space. So I make a little change, and then go back, run my tests. And now I have both tests passing. And now my feature is complete. So I can go back to designing features. So in the meantime, what happens? You check that in, it goes out into production, or maybe it goes into a QA environment. Somebody else is banging away at it. And what actually happens at this point is you don't get to design any more features. A bug gets reported. So now what do? Well, you actually go through this entire process again. So something went wrong. And how did that happen? Because we had tests, they tasked. How is it possible that anything went wrong? Well, there's a few things that could have happened. One is there could have been incomplete test coverage. So there may have been 5 features, and you only wrote tests to cover 3 of them. So you have a little gap between what was expected to happen and what actually happened. Another thing is incomplete feature definition. Is at the beginning, you didn't accurately list out everything that should happen with this function. There was something that was missing. And the third one, which happens a lot as well, is somebody's using this in a way that it wasn't intended to be used initially. And usually the answer to that is go over to them and say, don't do that. But you don't know until you start looking into the bug report and figuring out what happened. So here's my bug report. When I entered a username that had both leading and trailing white space, the application received a string that had no leading white space, but still had trailing white space. OK, so that sounds like it's a problem with my trim function, number 1. That's good. So I'm going to go back and look at my requirements. And so I said, okay, remove leading white space. Yeah, so we know that worked. Wrote a test for that. Remove trailing white space. So we know that worked. And wrote a test for that. Problem is that there was actually a third requirement that we didn't think of initially. And that's if the string has both leading and trailing white space, then we need to remove both of those and return the result. So that was the gap in the test coverage. We didn't have a test to cover that case. So now that I figured out what's going on, I need to go and write a test that shows this bug. So here it is, test trim with leading and trailing white space. And in that case, it's following the same format as the other tests that I had here. I'm just putting in a different input. And so that test fails. And that's exactly what I wanted to happen at this point, because that means I've identified the bug and I know what to do to fix it. And when you look at the failure message, it actually shows you exactly what happened, and you can see that it does match up with the bug report. So it says that the expected value was hello world, which is a string, and then the actual value is hello world, and there's a bunch of spaces after it before it says string again. So that's exactly what the bug report said. We can go on now to write the code to try to fix that. So as it turns out, I just forgot to put a G on my regular expression. Go figure. So now I'll go back and run my test after I've made that change. And now everything passes. So I can close out that bug. I know that I've fixed everything. I also know that I didn't make any changes that broke the previous functionality that worked, because all three of my tests are green. If I had made a change that had broke either of the other pieces of functionality, then one of those would have failed, and I would have had to have gone back and fixed that. So now that it's passed, we go back into designing more features for the application. So some of the challenges for test-driven development on the web, really it comes down to the browser environment. Right? So usually JavaScript doesn't exist in a vacuum, like that trim function, which can pretty much be run wherever. It can be run on the command line, it doesn't matter. But for most of us, we're going to be writing code that is tied to the page. And that means that it's going to be tied to it using events. We're going to be waiting for users to click on things or move their mouse or have some sort of keyboard input. Another big problem is that execution can be synchronous or it can be asynchronous. Synchronous code is really easy to check because you just go through in one straight shot. Asynchronous code, very difficult to check because you call some code and then you have to wait for something to happen, and then when that thing happens, you have to resume. It can be a real big pain in the butt. And of course, different browsers behave differently. And there's nothing we can do about that. It's something we deal with on a daily basis. But it makes it really difficult because you could test something in one browser and everything works, and you test it in another browser, half of this stuff fails. And so you always need to be testing in multiple browsers, one of the banes of our existence. And so YUI Test tries to help with this as much as possible. So one way is there's simple event simulation across all A-grade browsers, as well as some others. And that lets you do things like simulate clicks and key presses and stuff like that so that you can actually test your JavaScript that is tied to events. There is asynchronous code testing, so you can tell a test to wait and then resume at a later point in time and resume the test. Different browsers still behave differently. Sorry, there was nothing I could do about that. So just very simple syntax for event simulation. And this shows you all of the basic mouse events that you can simulate using YUI Test. So at its simplest, you can just access the methods off of the yahoo.util.userAction object. And you have methods for all of the basic mouse events: your click, mouse over, mouse out, mouse down, mouse up, and double click. All of those you can simulate. And for each of those, you can either pass in just a single argument. If you do, then it's either the ID of the element that you want to simulate that event on, or it's the actual DOM element itself. If you choose to pass in a second argument, then that's basically an object literal that has additional information that you want to be put onto the event object that you're going to get. So in this example, I'm putting in a client X and client Y value. And so when your event handler fires, assuming that it's actually relying on those, it will get client X and client Y on the event object with these values. And so the basic key events as well, key press, key down, key up, work the same way. For each of these, though, you probably want to always pass in a second argument with either the car code, which is just for key press, or key code, which is for the other two. That's usually the type of information that you're looking for with keyboard events. So I'm going to switch over to a live example now and pray that I'm able to write code in front of other people that works. So this is just a very simple example that I wrote up. And basically, it's an implementation of a tooltip. Really lousy tooltip. Don't copy this. It's bad code. Hey, my wireless network is working. So if I move the mouse over this text, I get this yellow box. Right? Very simple, very basic, no frills whatsoever. Mouse away, goes away, mouse over, comes back, et cetera, et cetera. You can see that it actually is dependent on where the mouse is as to where that shows up. So what I'm going to do is go over. Before I start, just wanted to show you this very basic template that you can use to set up tests, which already has all the JavaScript and CSS in it, and then the boilerplate JavaScript that I talked about afterwards. So I'm going to start out with a new file. And let's call this and I'm just going to grab all of the stuff that I had in this other file to implement the tooltips and just copy it over. And really the point of doing this is not to bore you. It's to show you how quickly you can set up these tests. So I'm going to grab this. Have the extra HTML and JavaScript that I need. Paste it in here. So that's all of the code. You can see really simple, inelegant, ugly. But now I can go down and just call this some tooltip tests. And so for my first test, I want to test that the tooltip is being displayed when mouse over happens. So we'll call this test show tooltip. And I'm basically going to start out by using the mouse over event simulation. So say user action dot mouse over. There's a test element that I had defined previously up at the top here. So I'm going to cause a mouse over to happen there, and I'm going to pass in some information because I am actually using client X and client Y in the code. And after that, I basically want to test for a few things. One, I want to test that the tooltip is visible. I want to test that it's in the right coordinate, X coordinate, and I want to test that it has the right Y coordinate. So I can do that by writing some asserts down here. So I know that the tooltip should be visible. So we'll test visibility. It should be set to visible. And I also know where it should be positioned left and right. So I'm actually just augmenting those by 5 pixels up here. So I'm just going to test. So I know that left should be 25. And I know that top should be 35. And assuming that I didn't introduce any syntax errors, as I was just typing right there. See, okay, so I have an unexpected error, which is okay. We can go back and fix that. But you can see that the tooltip is actually being displayed. And as you saw before, the only way the tooltip to be displayed was if you use the mouse over. So we know that the mouse over simulation actually worked. we can go back and let's see, so it said tooltip was undefined, and of course I named it hint and not tooltip. Just to confuse myself. Okay, so now I see that the test passed. So I know that the tooltip is now visible, and I know that the left and the top coordinates are correct. So one of the things that you should not do, and I was just leaving this up so you could see this, is that once a test is over, you should clean up the environment so the next test can run clean. And in order to do that, YUI Test provides on the test case two methods, which is set up and tear down. Now, setup gets run immediately before every test in the test case, and tear down gets run immediately after every test in the test case. So that gives you the opportunity to both set up the environment in which your test should be run, and then also to reset the environment once you're done. In this case, I really want it to be one and the same. I want the hint to be invisible when I start and when I stop. So I'm just going to set that to hidden. And if I go back, you can see that the test has passed, but you never actually saw the tooltip come up because it was too fast. But now I can go in and also test that the tooltip was hidden correctly. And for that, I'm going to start out and actually just show it, because I don't want to test the show ability. I already have a test for that. So I'm just going to start out by showing it by default. And now I want to simulate a mouse out to hide the tooltip. So we'll say user action dot mouse out on the test element, and I don't need any extra information after that point. But what I do want to check is that the thing is now hidden. So say test element.style.visibility, we're comparing it against hidden. You can go back and run this. Clearly, I have a typo in my test because it's failing. So let's see. Bonus points to anybody who can point it out. What? That would make more sense. See, that was a test. You guys passed. There we go. So now both of them have passed. And of course, you didn't see anything because it all happened too quickly, but you know that everything worked. Event simulation. It's a test reusable widgets, so YUI does this. Makes it easy if you're working with stuff like the menu or tab view or stuff like that. You can actually write unit tests against all of this functionality and then run them. You can actually use them to do functional tests. There's a really great tool called Selenium that its main goal is to work with functional tests. And YUI Test is not a replacement for it. But if you want to do some basic functional tests, then you can actually use this event simulation to do it. And for fun. It's actually a lot of fun to play around with just to see what you can get to happen on a page. So asynchronous tests, which is one of the other interesting features, there's two ways to accomplish this. And both involve calling the wait method. So wait can be used in one of two ways. The first way is kind of like set timeout. So you pass in a function as the first argument, and then you pass in a delay as the second argument. And then after that delay, the test will resume by calling the function that you passed in. And that function will be called within the scope of the test case object itself. So all of your references to this will all remain how they should. You don't need to worry about binding it to anything. The other way to call wait is to specify just a number as a timeout, and then later on call resume. And basically, if you call wait with a timeout like that, if resume is not called before that amount of time has expired, the test is considered to have failed, and you'll move on to the next test. The goal is to get resume to call before that timeout happens. And that's basically just a safeguard to make sure that you're not waiting indefinitely for a test to happen that just isn't going to happen. And so here's how you use the first one. Say this dot wait and pass in a function and pass in the number of milliseconds to delay before running that function. And then usually when you're using wait and resume together, it's in something like this, where you're dealing with custom events, or any type of event for that matter, where you do a bunch of setup, you set up an event handler, and then call wait with a specific timeout, and then in the event handler, you call resume on the test case object itself, and pass in a function that will do asserts for you. And that's just all kinds of hoops to jump through to get this to work correctly. But once you do, once you get it, it's really easy. So since the last example went so well, we'll take a stab at another one. Basically, this is using the YUI animation library to just move a rectangle over. Nothing very exciting. It's very basic, again, not very complicated code. But you can still write some tests to make sure that it's working the way that you hope it should work. This time we'll see if we can do it without any errors the first time. So start out with this base template. And just going to grab the code again from the sample file that includes the animation library. And just paste it in here. So in this case, I actually want to remove this code out here because I'm going to put it inside of some tests. I'll come back. We'll just name this test case animation tests. And we'll test moving the box to the right. So that's the animation code that we had on the other page. And since animation is inherently asynchronous because it uses timeouts to move things piece by piece and then allow the browser to refresh, we need to use the asynchronous parts of YUI Test in order to test it appropriately. So in this case, look at the animation. Basically says we want to move the left coordinate to 300 pixels and have that take about 2 seconds. Now, because timeouts aren't all that accurate in JavaScript, I can't just say, try something after 2 seconds and it should work, because there's just not that level of accuracy as far as milliseconds go. So I actually need to give it a little bit of a break in order to test that it's worked. So if I want to use wait like a timeout, I can do it like this. And maybe we'll give it an extra 100 milliseconds just to make sure that the animation has finished completely. And basically in here, all I need to do is make sure that the left coordinate is where I expect it to be now. So we'll throw in an assert. And it should be at 300 pixels if everything has gone correctly. So we'll try box.style.left. So you can see that the test actually waited for the animation to happen. And do that again. And then you can see that it passed. So we know that it got to the right spot. The other way of doing it, to use the resume method, would be to use the animation objects on complete event. So what I would do in that case is, again, I want to give it a little bit of extra time just to make sure. So waiting an extra 100 milliseconds won't hurt. And I want this function to run in the scope of the test case, so I'll add in those extra arguments. And we'll basically say in here, this dot resume, and pass in the function to do the assertion. And again, we're just going to check the left position of the box. So it looks a little bit different than the other one. The important thing is to start whatever operation you're doing, in this case the animation, before you call wait, because nothing will happen after wait is called other than waiting. So in this case, it looks exactly the same. We're just using a different method for asynchronous testing. And so those are the two ways you can decide which way works best for you and what it is that you're trying to test. A word of warning, though, you shouldn't be using this to test the responses that come back from the server when you send an AJAX request out. That's actually something that should be happening on the server. Right? The server has its own inputs and outputs that it should be testing for. It's not your job as a JavaScript developer to test that. What you should be testing is that you've sent all of the appropriate data to the server. So you want to go all the way down to the point that you are passing data into Connection Manager, make sure that all of that data is as intended. And then on the other side of things, you also want to test that the way that you handle certain responses is appropriate. So you want to be able to simulate the different responses that you're expecting to get back from the server, pass that into some function that's supposed to be handling it, and determine if it's handling it correctly. There's never a reason to go to the server when you're running any of these JavaScript tests. So some of the other things that you might find interesting about YUI Test. Test suites are a way to group test cases together. So if you have a bunch of test cases that are related, you can create a test suite and then add the test cases to the test suite and then add the suite to the test runner. It's really just a way for you to manage all of the tests that you have. Test suites can also have setup and tear down methods, just like test cases can. In that case, the setup will be called just before the first test in the test case is called, and tear down is called just after the last test in the test case is called. A little bit more powerful functionality that you may not need, but it is there if you do. You can actually hook into the test runner object if you want. It's completely event-driven, and that's by design. Because by default, we have this test logger that outputs information about tests. But that might not be the appropriate visualization for you. You may want it in some other sort of report format. And so the events give you a way to hook into what's going on with the test runner so that you can create your own sort of visualizations. Each event provides the results to that point. So you can actually track how all of your tests are doing after each test is run. Yeah, and as I said, test logger is just a base visualization. You can certainly design your own, and I would encourage you to do so, because there's any number of ways to represent this data that might be useful to you, and only you know that. So here are all of the events that are exposed by test runner that you can hook into. You can see it's pretty much every part of the test running lifecycle. So you can go ahead and subscribe to those, throw in alerts if you want, have it output someplace else, pretty much whatever makes the most sense. There is a test reporting object, yahoo.tool.testreporter, and that will basically take the results that are returned in the complete event, and you can submit those to a specific URL. It does that via a form post. By default, it's formatting that data in XML, but you can also specify to format it in JSON if you want. It's also really easy to write your own formats to post those to the server in. So that way you can actually set something up that just posts results back to the server for you, and you can generate reports off of that. So some recommendations. If you want to get started with test-driven development and unit testing, I I really like the idea that for every JavaScript file that's checked into source control, to check in a corresponding test file for it. So maybe you have some sort of convention, like if the file name is file.js, you'd say file_test.js. And even if the file is empty, just having that file in there will at least trigger you to stop and think, oh yeah, I should be writing tests for this. Start writing tests just for bugs that you get in. And nobody is going to go back and write tests to cover every piece of code that they've already written. Nobody has enough time for that. What you do have time for is, as those bug reports start to roll in, to stop and write a test to make sure that you've really isolated what that bug is, and then go about fixing the bug using that test. And slowly but surely, as bugs continue to come in, as we know that they tend to do, you'll end up with a really comprehensive library of tests to run. If you're going to be starting on new features, you may want to consider starting to write tests right from the beginning. I mean, it's completely up to you, right? This is all kind of idealistic chatter. But if you feel like this would be useful to you and something that you want to do, then the time to start is with any new feature that's coming down the road for you. And one of the things that I usually suggest is for each object, create a test suite, and then for each method, create a test case. And then in that test case for the method, test all of the inputs and the outputs in individual tests. And if you can, automatically running tests is really helpful, whether it's being run like once a day or every time somebody checks in or anything like that. It can be really, really helpful to just have that sanity check periodically to make sure that there were no errant check-ins that are breaking things and nobody knows about them. So some of the stuff that is coming in the future of YUI tests, specifically for the version that comes with YUI 3, will be mock objects, which gives you a little bit more control over making sure that data is going into and coming out of objects that you don't control. There's more simulated events on the horizon, some better error detection, so in case there's actually an error in your test and not in the code that you're testing, we want to be able to show that to you in a more logical way. And also, hopefully some new visualizations, so we'll have different ways to display the test results data to you. So just to go over the test-driven development cycle, it's really pretty simple if you just keep this in mind, is that the first step after designing features is to write some tests. Then you write code to make sure that those tests pass. Run the tests. If they fail, go back and write more code. If they all pass, then go back to the beginning and start over again. And this is the URL where you can go and learn more about YUI Test.